Hello everyone. In this video we are going to talk about the basic coal ingredients and their effect on the furnace design and the classification of the coal. The basic ingredients of coal are volatiles and carbons, fines, ash and quantum of ash. Their percentage and nature control the boiler design to adopt a particular type of coal and effect of available coal on the performance of existing boiler. Now let us discuss the effect of each of these components. First, let us see what is the effect of volatile and carbon. The percentage of volatile and nature of carbon are mostly responsible for the furnace design. When the coal starts burning on the grate, all the moisture is removed from the coal by the time temperature increases 300 degrees centigrade. At 400 degrees centigrade only, some type of coal mass melts and acquires plastic form. This peculiar behavior of coal is called caking. Caking. At 500 to 600 degrees centigrade, the plastic mass gets solidified again, forming a mass with holes within the coal. At this juncture, the rich hydrocarbon gases, which are nothing but volatiles, they get released from the mass. The volatiles which are released need additional air to burn, as the primary air leaving the bed is used in coal burning. This is generally done by supplying secondary air over the bed through a number of passages which are located above the fire bed. The second second component is fines. Fines is not the property of coal, but in the process of handling and transportation, the fines are generated. The percentage of fine in coal is also increased by grading and crushing. The use of coal with fines is limited. The coal size of 6 mm is limited to ram type stroker. Other strokers can tolerate coal size up to 3 mm. The coal dust cannot be used in any of the furnace except in pulverized firing. The next important constituent is ash. The ash consists of shells and clays, calcium and magnesium carbonates and organic pyrites. The constituents of ash are not combustible and do not contribute to heat release. The major troubles this ash causes some major troubles during the combustion, such as it reduces the calorific value per kg of the coal. Then the ash being finely distributed with combustible constituents, they keep on interfacing in combustion of combustibles. More the ash content, slower the rate of burning in the furnace. Slow rate of burning tends to develop lower furnace temperature and induces a good amount of air through the coal bed without taking part in combustion. Therefore, slow rate of burning of high ash coal needs much larger excess air to be supplied, and thereby further reduces the furnace temperature. Then quantum of ash. Another important constituent is the quantum of ash. The ash content interferes with the combustion of coal and reduces the temperature of combustion zone. Higher ash contents low burns the higher the ash content, the coal burns slow compared with the low ash content coal under identical conditions of the feed rate and excess air supplied. Therefore, given ash content coal can burn at different rates depending on how fast and how effectively surrounded by air. So this phenomena can be observed by more intensified glow of the coal burning. Now let us talk about the classification of the coal. So as we have discussed that coal is the most important solid fuel and its main constituent is carbon. So the coal passes through different stages during its formation from vegetation, and these stages we are now going to discuss. So this coal can be classified as peat, lignite, bituminous coal, anthracite. Then there are some more classification of the coal, that is wood charcoal, coke and briquettes and pulverized coal. So let's talk about the peat. Peat is the spongy humidified substance and first stage at which the fuel is derived from the wood and vegetable matter. Thus, it possesses constituents very nearest to those of wood with 30% moisture. It has lowest calorific value about 1400 and 500 kilojoule per kg, 14,500 kilojoule per kg, sorry. It is mainly used as a fuel in gas producer plant. Otherwise, other varieties of the coal are derived from the peat also. Then lignite. Lignite is found next to peat. It is a soft coal composed mainly of volatile matter and moisture content with low fixed carbon of about 60%. Its appearance is brown and it contains high ash and low heating value. It is a low grade fuel having a calorific value of 21,000 kilojoule per kg, and it is too brittle and hence it is converted into briquettes, which can be easily handled. It burns with heavy smoke. There are comparatively large deposits of ignite in Kashmir, then Neyveli and Rajasthan. This Neyveli power plant actually uses this type of fuel. The next type of coal is the bituminous coal. See, bituminous coal's formation is next to lignite. It is shining black in appearance. It contains about 70% carbon and the remaining as a large percentage of volatile matter. Thus, it is easy to ignite and it burns with yellow smoky flames. It has an average calorific value of 31,500 kilojoule per kg. In India, its reserves are available in Bihar, MP, West Bengal and Orissa. It is used for producing producer gas. The next type of the coal is the anthracite. So anthracite is the next generation of bituminous coal and it has the highest rank. It is a hard coal composed of about 90% carbon with little volatile content and practically no moisture. It is brittle and it has a shining black luster. It burns without flame and smoke, but it is difficult to ignite. It is non-cracking and it has minimum ash, sulfur, volatile matter and moisture content. It has highest heating value, approximately 36,000 kilojoule per kg. In India, its reserves are available in Kashmir and the eastern Himalayas, and it is used as fuel in steam power plant. Yeah, apart from these classification, so few more classifications are also given. That is wood charcoal, coke, briquette, and pulverized coal. Okay, I have written coke and briquette as the same thing, but it is different. Okay, please make this correction. So let us talk about wood charcoal. Wood charcoal is obtained by heating of wood up to a temperature of 280 degrees centigrade in the absence of atmospheric air. During this process, the volatile matter and water are expelled and the residue is charcoal. It is an excellent fuel, but it is very costly and its calorific value is about 28,000 kilojoule per kg. Next is coal. So coal is obtained from bituminous coal by the carbonization process. That is, the bituminous coal is heated strongly in the absence of air for 48 hours. Thus, the volatile matter present in the coal is driven off. Coke is dull black in color, hard, brittle and porous. It consists of 90 to 95% carbon, small quantities of sulfur, hydrogen, nitrogen and phosphorus. It is a smokeless and clear fuel. Its average calorific value is about 32,500 kilojoule per kg. It is used in steam power plants and blast furnaces and gas producers. The another type of coal is the briquette. So it is produced from finely grounded low grade coal actually by the molding operation. The coal powder is mixed with a suitable binder and it is pressed together to form blocks or briquettes. The binding material may be pitch, coal tar, crude oil or clay. By this method, the heating value of the low quality fuel is improved. Then the another type is pulverized coal. So crushed coal in the fine powder form is called pulverized coal. Okay, it is a powdered form of the crushed coal, you can say. So during combustion, it floats and thus comes in the better contact of air, improving the combustion efficiency. Pulverized coal has flexibility of control, complete combustion with less excess air and high flame temperature. Pulverized coal is used in cement industries and in most of the furnaces. So this was about the basic ingredients of coal and the classification of the coal.